Okay, hey, dependency injection by everybody's favorite tech YouTuber, Code Aesthetics.
Dependency injection is a term I don't love because it sounds a lot more fancy than it is. Dependency injection is simply when you have a piece of code which uses another piece of code, and instead of using that code directly, it's passed in instead. When you pass something in to be used, we call it injection. We inject the dependent code into the code that uses it. While this part is quite simple, it unlocks some very powerful side effects that we're going to cover.
I do really like a dependency injection until dependency injection becomes the ultimate solving hammer for all things, right? Because at Netflix, we have this thing where everything became DI, and eventually, like, every single thing was a functor with, like, 6 arguments that's just producing. It just got out of control, right? And I forgot to turn off alerts! It just got out of control, and when it gets out of control, it becomes unfun really quickly. You know what I mean? It becomes unfun real quick.
We have a business app where users can chat with their coworkers. They can also send pictures and files to each other. When a user sends something, the file gets uploaded to our attachment service.
I work at Netflix.
The attachment service is responsible for storing, retrieving, and processing all attachments. We're going to build up this whole service using dependency injection, and we'll see what it enables us to do. When a user sends a message with an attachment, the message text gets sent to our standard chat service.
Is this where they're going to use Theo's upload thing? Is this the video? Dependency inject a little upload thing into this chat service? Is that what's happening right now?
We want people to receive their messages almost real time.
By the way, I heard this guy. Okay, I got to get in contact with Code Aesthetics, but I heard word on the street is that he built this is all in Python, and it updates every single like character on the screen one at a time and goes really, really fast. Like that's what I've heard. It's like a super terrible implementation. It's not fast, but it totally is amazing. No shot. Yeah, that's what I heard.
So this service is all about speed. The attachment, on the other hand, gets uploaded to our attachment service. There's an endpoint in our node service, attachment/upload, that the app connects to and uploads the file. The attachment gets stored on the disk temporarily, processed in a few ways we'll talk about, and then uploaded to its final destination.
Let's go.
The default storage location is an S3, a part of Amazon's
S3, the world's largest graveyard. You thought my GitHub was a large graveyard of things people will never use again? S3. Literally the largest.
Web services. It's a simple storage service that lets you put up files and pull them down. We have some code here that takes the uploaded file and then uploads it to S3.
Oh, look at all of this. Okay.
Unfortunately, simple and elegant doesn't always like to coexist with business. While S3 is nice and straightforward, and most of our clients are okay with it, we have a few firms that don't want us to permanently store their data. This means we actually need our service to handle multiple storage locations. Then, depending on which company a user is from, we need to put their attachments in the right place. Most of these picky clients just give us an SFTP server to connect to, but one really wanted us to use WebDev.
What's WebDAV? What's that? AWS does not equal simple anything. I mean, it's true. But I mean, do you see what's happening right here? We are about to get ourselves into a couple little cool patterns going on here. So the first pattern, obviously, is the strategy pattern. You want to be able to pass in a singular item in which has an interface in which has several underlying features. You know what I mean? And so, or several underlying implementations. So we're going to get a little strategy. We're going to get a little DI. You know what I'm talking about? It feels good. It feels good.
Our first thought might be to simply extend our upload code with some if statements.
I'm going to vomit and my
then
screen
have the
tearing's
caller
awful.
of the upload method pass in where to upload the file. This is awkward.
Classic strategy pattern going on here, okay? Look at it. Would you look at that? Would you look at it? That's classic.
For a few reasons. First, this one class has a ton of responsibility, making the code pretty ugly. The code for SFTP is intermingled with the code from AWS and WebDev, even though they're pretty different.
I don't think he meant to say that, but I'm pretty sure it just came out as this class has a lot of responsibility, like making the code ugly.
First, this one class has a ton of responsibility, making the code pretty ugly.
It's not meant that way, but it's so good when you... It's just the right abstraction when you hear it that way. It is true. The responsibility of this code is, or the responsibility of this class is simply to make it ugly. That's it. It's a very poor job.
The code for SFTP is intermingled with the code from AWS and WebDev, even though they're pretty different. There's a lot of paths the code can take, and that makes the code harder to understand.
Yep.
Second,
it also makes
using
it
the class
impossible to
isn't
test.
very simple.
It's impossible to do anything with. Right?
We have this one upload function which needs a bunch of info for where we're going to upload the attachment.
Yeah, it's just the worst.
But what info it needs is very different depending on where it's going. If it's AWS, we need the AWS keys. If it's SFTP, we need the address and private key. And WebDev needs a URL and auth key. So we're kind of forced to have a bunch of these optional variables that need to be filled out in certain cases.
I think the default thing that people kind of reach for right here when they see this situation is using like a little mapping and generics in TypeScript to kind of enforce that if you pass in this type, it gets these parameters, which can be a little interesting. Not an enum. You wouldn't use an enum. You'd use like a type mapping to solve this. Typically, people avoid enums. They use a const as const. You know what I'm talking about? See, in TypeScript, remember, there's a variable, there's a const, which is a constant pointer to a variable, and then there is a const as const, which is a constant pointer to a constant. You gotta remember, there's like a lot of things in JavaScript that you don't think about, you know? Would you steal a
and
car?
And then comments to tell you which ones to fill out.
You wouldn't use an enum
This makes it pretty easy for the caller to make a mistake.
Clear as mud. It's actually really, when you think about it in the terms of what's it called, of C, it actually makes const make a lot more sense. Yeah, I see right here. I see a const star as a const, right? It makes a lot more sense when you think of it in terms of C. There's a pointer, there's a constant pointer, and then there's a constant pointer to a constant. Like, you got to think of it that way. It honestly makes life a lot easier.
And finally, the part of the code that actually calls upload over here needs to have all of this destination-specific context to perform the upload.
Hold on, I just have to find out now. I'm sorry that I'm totally derailing the video, but now I got to find out. Can you have a pointer to a constant? Is that something you can do in TypeScript land? Can we go like this? Let foo equals a5 as const. Oh, yeah. Oh, yeah. Oh, yeah. Oh, yeah. Yeah. You can have a pointer to a constant. Look at that. See, there is the 4 types of pointers. See, this whole time. So that means you can say foo is a6. Oh, never mind. It's not a pointer to a constant. This is stupid. You can't change the pointer. Okay, whatever. Okay, back to the thing.
But really, at this phase, it just wants to upload. The part of the code that knows best which company a user is from and can deduce where the file should go is up here at the beginning of the request.
Yes, because it
but
already
right
knows.
Now, we're forced to pass all of this information around.
Yep.
Let's see what happens if we use dependency injection instead. Let's
go.
create an interface that represents our attachment storage, which contains a key upload method that does what the request handler wants to do.
Perfect.
Upload
I like this.
an attachment.
Like it.
Then we create 3 different implementations of the storage interface. The configuration for each is passed into their constructor.
Beautiful. This is
There's
called the
no
strategy
more
pattern.
optional variables that sometimes need to be set.
The
You
strategy
require
pattern,
exactly
babies.
these values, and you get an error if you forget one. So now, once the user is authenticated, and we know which company they're from, we create the storage that the request handler should use.
Yep.
Instead of the configuration needing to be passed all the way to the request handler, only the storage is passed to, or injected into, the request handler. It's not aware of which storage is passed in or where the file is going, it just knows that it can call upload. That said, this construction code is still a little too complex to put here. So let's see if we can clean this up. If we look at the input here, it's really just this company configuration. And the output is this storage.
We got ourselves a little bit of a
So we can just move this out to a
ourselves a little bit
factory.
of some sort of factory going on here. Hey, oh, beautiful wife. Thank you very much. Love you.
Great. But saving to the final storage destination is the last step of the process. We have all these other stages that the upload goes through. We run each upload through a virus scanner.
Does he work at Slack or Teams? Which one is it? Pattern as a strategy pattern. Let's see. Wait, how to discover the different pattern as strategy pattern? I mean, it's obvious here. This is obvious why this was a strategy pattern, right? Because you had a series of if statements with a bunch of different items within it, right? It became very clear that under this condition, you want to do it this way. Under this condition, you want to do it that way. Under this condition, you want to do it this other way. It's a strategy, right? It's like it's within the name itself. You need to take a different strategy based on different things. So you interface it out so they all have the same input, and then you have then the actual concrete implementation does something. It doesn't, DI doesn't help with reconnecting sockets. Yes, it can. It can.
The last step of the process. We have all these other stages
that
the upload goes through.
They should never know anything about it. That's a real thing. A socket, you could wrap the socket class, so it should never
We
even
run
know
each
about
upload through a virus scanner. This checks the files for signatures of obvious viruses. Then, if the file is an image, we scale it down to a max width of 2500 pixels. This is what we display to the user when they click on an image, because it uses less bandwidth and loads faster.
Classic.
Then, the file goes through preview generation. This is basically the thumbnail that pops up underneath an attachment in the chat, so the user can see what the attachment is without fully downloading it.
Nice.
Then the last step is encryption.
He must work at Slack.
If we're storing the files on Amazon's S3, we pre-encrypt the files before sending them up. That way, if there's a security breach at Amazon, we can say they're encrypted when we have to send out one of those "we were hacked by the way" emails. So let's see how we can make each of these requirements fit cleanly into our service. For the virus scanner, we currently use a scanner called Threat Protect.
If you were hacked, wouldn't you just, wouldn't they already get like the salt and the decryption? I'm a little confused about that one.
However, Synergy's security scanner has much better detection KPIs, and our plan is to switch to it. But sadly, we haven't finalized the deal with Synergy. We're only allowed to test with it in our development environment, not in production. No worries, we can create a shared interface for our two scanners.
Strategy pattern again,
and
people.
On initialization, we pick one.
Again, this is just strategy pattern all over again, over and over again.
And inject that one into the request handler.
The nice part is the strategy pattern works with functional programming as much as it works with
Synergy security is initialized, and in production,
all the same thing.
The old Threat Protect scanner is created. Our request handler just scans the files, but doesn't know which scanner is doing it. For image scaling, we use the Sharp library. In order to inject that, we simply wrap it up in an image scaler interface. The interface also contains a method which tells us if an attachment supports scaling. We inject it into our upload request, and only scale if the attachment supports it. Preview generation is the most complex given how many types of attachments there could be. It's just a series of strategy
patterns going on here.
We have an interface that represents the different preview generators.
Let me guess, you have an
interface,
takes the then you implement it?
And then returns the preview image. We have one implementation that handles document files like Word docs, slides, etc. One for videos, which extracts the thumbnail from the video, and one for images. But the image one can thankfully just reuse our image scaler. We just inject the same image scaler from before
telling me that code is about patterns?
Preview generator.
Yeah. Honestly,
so we have all these preview generators.
Honestly, the reality is that almost all programming comes down to like two patterns: the builder pattern and the strategy pattern. That's it. You use a little, you use a little bit of dependency injection, awesome, and you couple that with a little bit of building and a little bit of strategy pattern. You pretty much just covered like 95% of all programming, right? That's pretty much it. That's all there is. It's the observer pattern, all that. That's like the other one that's kind of used in its own little area, right? Polymorphism is a strategy.
But we only need one at a time, depending on which file type
strategy,
is being
dog.
uploaded.
The
upload request shouldn't need to worry about these details.
It's an implementation.
We'll inject a factory which takes on the burden of deciding which preview generator to create.
Chaining pattern is not a pattern. That's the builder pattern. Chaining is a builder pattern. Monads are more like tools than they are anything else. Is mayonnaise a strategy? I think so.
The factory takes in the MIME type of the upload and then returns the right preview generator to use. So now the upload can simply just ask the factory for the preview generator.
Looks good.
And then use it. And lastly, we have encryption. We only have one implement.
This isn't complicated. Someone said, why would you ever do this to yourself? This makes life 1,000 times easier. Simple understanding of a basic pattern to interface things out and to use the strategy pattern. Like that's very simple, right? There's nothing about that, and it just gets a lot easier. You know what I mean? This is not very, very hard. Encryption key, assword. You're telling me I asked you to have the most secure password ever, and you chose assword. Right? It's just about solid, to be honest. I don't do any of those fun little phrases everybody uses. It's mostly it really, this is most programming, okay? Most programming is you prototype the shit out of something. When you're done prototyping it, you look at all the places in which you failed, all the places in which were hard, then you implement the actual thing, and that's that, okay? That's really all programming is, and sometimes that looks like strategy pattern. And sometimes that's not. Solid and dry. Dry sucks. Dry is one of the worst pieces of advice of all time. Okay? Because the thing is repeat yourself. There are times when you should repeat yourself. If you think repeating yourself is the end game of, or if you think don't repeating yourself is the end game of programming, you make shit code, okay? That's why. That's what happens. I used to do the same thing. I did the same stuff, and guess what? Dry sucks. Dry is the root of all evil. Okay, first off, you didn't say the phrase correctly, and second off, it's not the root of all evil, okay? It's not the root. Everybody knows greed is the root of all kinds of evil, proper phrase. But dry makes things... Dry is what creates every framework you hate. I completely disagree. You go for it. Dry is not great. Dry works... Just go Martin Fowler and go, when you've repeated yourself 3 times, then refactor. I think that's a pretty good rule of thumb, right? You repeat yourself twice, not a big deal. Try wet. Get some, is that WAP? Wet ass programming? Is that what that is? I've never tried wet ass programming, but I hear it's great.
Of encryption.
But think about all these like little phrases, dry, solid, WAP, all those things, it doesn't matter. Write your function to do a thing. Write your function to make it easy to test, even though you may never test it. Boom. You've literally solved like 95% of all problems you'll ever run into. Okay? This like strategies people come up with, all that, it's just experience. That's all it is. Just, you won't think about it. I don't know anyone that's like, oh, solid. Here we go. Single purpose. No one does that.
We use AES. But the key is per user and comes from our
WAP
key
is the
service.
only thing that we need.
So we inject our key service into the AES encryption, and then the AES encryption into the storage factory.
Yep. This is enterprise programming.
Then whenever we get a request for a company that's configured to use AWS, the storage factory injects the AES encryption into the new instance of AES storage. Then the upload request gets this final constructed AWS storage and simply calls upload without knowing that there's this whole chain of connected functionality.
Yep, this is good.
And now we have our complete architecture. You can see that our service...
There's that, one thing Code Aesthetics does is he has the most nice Code Aesthetics things ever. But in the moment of, like, reveling in your own creation, the music, it rises.
And now we have our complete architecture. You can see that our service...
And just circumcises that music clean off. Just give us a second to revel in it. Maybe, just give us a moment. That was like the crescendo. Let us have the gasm. Don't just take it from us.
This is configurable from this one spot, which makes it super easy to change. Once our deal with Synergy Security goes through, it's just these 2 lines to change our service. Want to add preview support for a new file type? It just slots in like this. No access to the key server when running the attachment service on your local development box? No worries. We can just use a fixed key when running locally. Injection basically just lets us pick and choose from our compatible puzzle pieces and then slot them in when we need them.
Yep.
You'll notice that
he is missing the fact that it's the strategy pattern that allows for the picking and choosing. It's dependency injection that enables the passing it in. Right? There is like a very important difference right there, but
time in which
correct.
dependencies are injected varies a bit. A few dependencies are resolved and injected right at startup. This is often the most common scenario in dependency injection. But some dependencies are chosen and injected when a request comes in. In either case, the process is mostly the same. We have some code that accomplishes something, it lists the dependencies it needs, and so we fulfill those needs. You might wonder why go through the hassle of creating interfaces and injecting things when we only have one implementation.
This man has done a lot of Java.
We only have one implementation of encryption. Well, there's one big thing we haven't talked about. If you look at our architecture here, most of our components talk to each other through these interfaces, which are injected in. This means that each of these connection points, we can control what is being used. We've been using this to choose which implementation to use in our production service. But we can also make them use no implementation. We can use injection to inject fake or mock implementations instead.
Yep.
Which basically means we can slice and dice up our architecture to isolate sections of code during testing. Let's say we want to write a test for our AWS storage class. We can use a fake S3, which we run locally, that pretends to be the cloud service.
Yep.
Then our test can call upload, and we can verify that a file got uploaded to S3. But because of the encryption, we can't actually check the content of the file.
This is why a lot of times I always say there's kind of two parts of code you need to write. There's the logical part of the code, and then there's like the I/O async part of your code. Long as you can separate out those two facets, it makes it really easy to test without a whole bunch of mocking. I'm not a huge fan of mocking. I'm not a huge fan of all those things. There are a few times where it's necessary. I'm not 100% convinced it's a great thing, but you can do it this way.
And verify that
And by the way, another great reason why SquealLite is amazing. SquealLite allows for you to just point to a file, right? So you could create a database that is in the perfect condition, CP that file to a new location, and then just run the thing as a full-fledged end-to-end test, and it just does the right thing, and then you can assert the database at the end. There's something that's really cool. File databasing of SquealLite is one of the coolest features of all time.
Not to worry, let's inject a mock encryption that basically just disables encryption. When the AWS storage class asks us to encrypt a file, we'll just hand back a file that isn't actually encrypted. Now, our test is able to verify fully that uploading and only uploading works because we've isolated it away from our dependencies.
I generally have a hard time with these type of tests. You know what I mean? Because you're not really testing anything. You know what I mean? You're testing your not real encryption is not really encrypting. You're testing that your not real S3 storage is not really S3 storing, right? You know what I mean? I always have it, whenever it gets into this level of DI and testing, it's just what exactly are you testing? Because then you are testing that you're calling all these things. Your coverage goes up, which adds business value. I feel like end-to-end tests that actually do the right thing, because the problem is that this type of testing is great and all, but you know what you see right away, right here? What do you see right here? There's no try catches. There's nothing that's actually preventing issues. And what do you see right here? None of this will ever cause an error, right? There's this whole problem of error testing and what actual errors will return from actual services versus these dumb things that you write to in-place services. I always have a hard time. This does not feel like testing code to me. Honestly, this does not feel like code I would test. There's nothing here. This is just one giant grab everything, and that's that, right? It doesn't. There's nothing here that seems worthy of being tested, in my personal opinion.
What if we wanted to test encryption? Well, we could mock out the key store to return a key that we control instead of going all the way
I
to
don't think
the
there's
key
anything
service.
worth unit testing at this
Or
level.
if we wanted to integration test both our AWS code and encryption code together, we could do that by injecting our fake key store into the real encryption and then inject the real encryption into the AWS storage. A key thing here is that this is easy to do. A natural side effect of having nice code is that it's easy to test without needing to hack around the code structure. If you find yourself asking, how can I test a private method? Or I need to set some internal variable in order to test. That's a signal that you maybe need to pull some stuff out. That you need to isolate some part of it by separating
I do not like, I see the word mock down there. I don't want to see any of that. Get that there. But I like this. Good job, Cope.
I'm going to try something new with this video. I truly think you only learn stuff by trying stuff. So for those subscribed to my Patreon, I'm going to start including some light experiments with videos. For this one, you can download the attachment service I wrote. I want you to reconfigure the service by changing the dependency injection. And then you get to win some aesthetic points if you enter the results on the site.
Nice. Hey, look at those little points go up. Look at those little points go up there. I highly recommend that you go back here and you go and find this man's Patreon. And you go patronize him. Give him some patrification, okay? Do it. Great video. I loved it. The testing part, you know, I always am on the fence with that kind of testing. I see it so often, but the rest of it, beautiful, perfect, exactly the thing I wanted to see. You know what I mean? Great video, loved it. You guys should all take this to heart because there's some really good programming techniques in there. But I will make one kind of thing that I feel like is really important. There's one caveat I want to add to all of this that's extremely important, which is don't do those things right away. All right? Notice what he did in this video. He fixed code that was too complex. He did not create code that was all perfect and perfectly dependency injected out and everything. No. Start with the bad stuff, okay? See ya, oh camel, my camel. Bye, camel, my camel. Start with the bad stuff. Understand your program and what you're creating, and then start pulling things out. You gotta absolutely do that, right? It is one of the most important things ever. People often abstract entirely too fast. I just see it all the dang time. I start bad, refactor to worse. There you go. The proper way to go about this. Someone said, can you give us an example where dry is not good? I'd have to go look at it, but when you repeat yourself 3 times, consider refactoring, okay? 3 times, then consider refactoring. You know what I mean? Then your manager says, all right, next thing. Yeah, it could be. Anyways, just some thoughts of mine. New lighting I see. I know I'm still working on the lighting. I'm a little green, okay? I'm a little green. I'm sorry for my greenness. The name is, am I dead, Jen? Am I? I can't tell. Boom. Look at that crispy finger. Look at that crispy finger, Jen.